Hello everyone. Thank you guys for coming. Today we're gonna get rational. Um, we're gonna be talking about proportional relationships between ratios, rates, fractions, and then we will be using that information to transition over into looking at the proportional relationships between fractions, decimals, and percentages, which is what this lesson is all about. So let's get started. There we go. Good to be patient. It's a virtue. So, first of all, we want to talk about what ratios are. They are a multiplicative comparison of two quantities or measures. They are proportions that involve multiplicative rather than additive comparisons. This means that they are distinct entities which require two different measurements to make it up. The equal ratios result from multiplication or division, not from addition or subtraction. Um, Rates are a specific way to represent ratios, and they represent an infinite number of equivalent ratios. As we go through this lesson, we will be talking about proportional thinking, and it is developed through activities and experiences that involve comparing and determining the equivalence of ratios. Um, this requires solving proportions in a wide variety of contexts that are applicable towards your lives. So they are problem-based contexts and situations that are completed through reasoning, not rigid use of formulas. This means that you guys are going to be engaging in the material and you will be manipulating it and discovering for yourselves why ratios, rates, fractions, they're proportional to each other, and that will lead into you discovering why decimals, fractions, and percentages are proportional to each other. There are two different types of ratios, the part-to-part ratios and part-to-whole ratios. Part-to-part ratios are relating one part of a whole to another part of the same whole. So this would be like saying 9 girls to 7 boys. This ratio of 9 to 7, which is not 9/7 because part-to-part ratios are not fractions. They cannot be fractions. And the part-to-part ratios are relating one part to another part. Whereas in the part-to-whole ratios can express comparisons of a part to a whole. So the number of girls in a class being 9 to the whole class being 16. This ratio is represented as 9/16, and it can be thought of the fraction 9/16 because part to whole ratios can be percentages and probabilities as well. So the two types of ratios are part to part and part to whole. Rates are ratios as well. They involve two different units and how they relate to each other. Relationships behind two units of measures are also rates. And the examples that I gave were comparing inches per foot, millimeters per liter, and centimeters per inch. That is just explaining that those relationships are related to each other. So the one unit of measure being centimeters is related to the other unit of measures of inches. And rates are also represented as an infinite set of equivalent ratios. So an example of this would be if I were to say I run 10 miles in 3 days. Funny, I do not run. I love swimming, but running is not my thing. But let's just say I run 10 miles in 3 days. This rate of exercise could mean that I could multiply it by 2, and that would get me to the equivalent ratio of 20 miles in 6 days or 30 miles in 9 days and so on. It's that infinite equivalent of ratios. Ratios and fractions may be overlapping concepts, but they are not the same thing. They are similar in the sense that they are represented symbolically through the fraction bar, but ratios are different than fractions because ratios cannot be added and fractions can be added. Ratios are relationships that involve multiplicative reasoning, not additive reasoning like fractions. And if you look at this chart right here, it compares and contrasts ratios and fractions and says, in the example, if you were to take 10/5, 5 is the number of parts in 10, whereas looking at it in the ratio, you can't quite do that because it would be 5 is the number of parts in another number. So those are just a few of the similarities and differences between ratios and fractions. And now that you know the similarities and differences of ratios and fractions, we're going to go through these examples, and I want you guys to be writing these examples down in your notes, be writing notes on new concepts, anything that stands out to you, and because you are going to take a picture of your notes and upload them into Google Classroom, and that will be part of your participation points. So going off of that, the first example is the ratio of cats to dogs at the pet store is 3/5. And I want you guys to decide, is this a fraction, a ratio, or both? And you'll write that down in your notes and you'll explain why. So in this example, the ratio is not a fraction because fractions are not part to part. So that example is cats to the dogs at pet store, part to part, cat and dog. So that part to part relationship cannot be a fraction. It has to be a ratio. The ratio of cats to pets at the pet store is 3/8. The ratio is part to whole, and it can be adapted to say that 3/8 of the pets are cats. Therefore, this example is both a ratio and a fraction. And the third example, Mario walked 3/8 of a mile. Fractions are represented in length, so this example is a fraction, not a ratio. Now we're going to be getting into the proportional relationships between decimals, fractions, and percentages. As you guys know, decimals, there is a specific role of the decimal point because it marks the locations of the ones place or the units place. So if I were to say 3 and 80 or 3 and 85 hundredths, 3 and 85 hundredths, see, it's difficult sometimes. 3 and 85 hundredths, that decimal point is represented by the word and. 3 is the ones place, in this case it is the meters, and then and is the decimal place. 8 is in the tenths place, and 5 is in the hundredths place, which is why you would say 3 and 85 500ths. That is measurement in the metric system. The decimals, if you guys aren't interested in the metric system, then I can bet that you will be interested in the monetary system because money is just a part of life. Everyone engages in it without their daily lives. And when we're thinking about the monetary system, I gave you guys an example of money. So 172 and $95. The and is verbalized in the decimal point. 100, the 1 is $100. The 7 is 7/10. 2 is 2 singles. The 9 occurs after the decimal point. It's 9 dimes, which is 1/10 of a dollar. And as you can see here, it is in the tenths place after the decimal point. 5 pennies is 1/100th of a dollar, and that occurs right after the tenths place. So you can see the connection between decimals and the monetary system. So it's important to recognize a decimal point does mean something. It means it's a difference between cents and like thousands of dollars. As we have studied this, we know the models used for area grids, 10 by 10, area grids, area models, and empty number lines. We've used these examples to compare and contrast whole number relationships. So now we're going to use that knowledge and apply it to the fractions, decimal, and percentages. So in this first example, I walk you guys through the 10 by 10 area grid of 84 over 100, the fraction 84 over 100. And we can see that by this 10 by 10 grid, that 84 of the squares are filled in. So with 84 of the squares filled in, that means that it is out of 100. Being out of 100, that automatically connects to percents because percents are always out of 100%. So 84 out of 100, the 100 on the denominator gives you the clue that it's connected to a percent. 84% is the exact same as 84 over 100. Going off of that, the decimal is 0 and 84 hundredths. And that makes the connection because the decimal point that's right here, you move it 2 places to the left and it gets you to the decimal from the percent. I'm going to be briefly going over the conversions between fractions and decimals, decimals to percentages, and percentages to fractions. And you guys have the notes here, and I want you to be taking notes on these charts. And very briefly, I am going to go over some of them with you, but I expect you guys to be active learners and be taking notes on this because it's going to help you throughout the rest of the work that you will have to complete this week. Fractions a decimal. You will divide the numerator by the denominator to get a decimal. And this is shown in the example here because I divided 2 divided by 3. And I received the decimal, which would be 6/10 repeating. And then you can go through these examples, but I wanted to briefly touch on the fact that I included the sales throughout the entire year. Out of 100, there were divided into first, second, third, and fourth quarters of the various percentages, fractions, and decimals, and they are the exact same. And I wanted you guys to see that through this pie chart, they're the exact same proportional relationships between fractions, decimals, and percentages. For example, as we go through and we compare fraction to decimal, the first quarter, 25 over 100. This can be simplified into the fraction 1/4. Yes. So going off of that, the fraction 1/4, which is 25 hundredths, 25 hundredths, that sounds familiar, 0 and 25 hundredths. So it would be 0 and 25 hundredths. That is the decimal equivalence of that. And I want you guys to go through each of those quarters and compare the fraction to the decimal, and then compare next the percent to the fraction and the decimal to the fraction. So you guys will be using these notes and you will be converting 15% to what fraction it would be. I want to see your work and I want to see you guys engaging in the material because that will help you as you move on to the next assignments, because you will be playing some fun games this week. But in order to master the conversion, you have to practice it. So before this video is over, I just want you guys to have those few announcements of be taking notes and upload them into Google Classroom, and then go through Monday's agenda for Google Classroom and complete the required assignments. And I will upload another video for you guys to watch tomorrow. Thank you very much. God bless.